Hello students, today we discuss different types of SHM motion, different types of simple harmonic motion, right? So first students we discuss different types of simple harmonic motion. Okay, different type of SHM, different types of simple harmonic motion that we discuss, different types of simple harmonic motion. Okay, see students, first we discuss it is question number 19 from our textbook, and it is the first case our oscillation of liquid in U-tube. Oscillation of liquid in U-tube. So see students, so suppose this is the U-tube. Okay, so now see what is the density of liquid in U-tube is rho. Okay, so students, in here first we prove in that case first we prove that motion of a liquid in U-tube is SHM. Okay, then after we find time period. Okay, first we prove motion of liquid in U-tube is simple harmonic motion. How to prove it, students? See, in case of any simple harmonic motion, force is directly proportional to displacement. So આપણે અગર આ પ્રૂફ કરી દેશું, force is directly proportional to the displacement, then it means motion is simple harmonic motion is SHM. Okay, so here we prove F means force proportional to displacement, right? That is our target. So now say students, next what is the density of liquid in U-tube is rho. Now suppose we apply pressure difference. Okay, due to the pressure difference, displacement of a fluid in a downward direction in a one tube is y. So what is the displacement in other arm in upward direction is also y. Okay, in one arm of a U-tube, what is the displacement of a liquid? Y. So that is in downward direction. So in another arm, y is in upward direction. Okay, I am downward, so I am upward due to the what? Pressure difference. Due to pressure difference P, due to pressure difference P, displacement of liquid in one arm of U tube and it is in one, suppose in downward direction. Okay, chalo. So now see, draw the another figure. Chalo. Now see, this is its initial level. Chalo. Here it moving downward direction. What is the displacement in downward direction? Y. So here same, the liquid is moving in upward direction by Y. Okay. So what is the total height difference between them? What is the total height difference between them? 2y. Y plus y. What is the total height difference in 2y? Because see, in first term it is moving in downward direction by displacement y. So in another arm it moving in upward direction by displacement y. So what is the total difference? 2y. Okay. So what is the total difference, students? 2y. So h is equals to what? 2y. Chalo. Now see, here we want to find, we want to prove this motion is SHM. If this motion is SHM, then force is directly proportional to displacement. That we want to prove. Okay, we want to prove force is proportional to displacement. So see students, what is the see, here we apply the pressure difference. Now what is the pressure difference, students? See, formula is H rho G. Formula of pressure difference is what? H rho G. So rho is the density of liquid and height. What is the height difference? 2y. Sure. So now pressure is equal to force by area. So force is equal to pressure into area. Now students see, now this is the SHM motion. See, 2 rho Ga constant. So F is equals to Ky, where K is a constant. What are the constant term? 2 rho Ga. That are the constant term. So we can say that F proportional to Y, force is directly proportional to displacement. So this is the motion. This motion means motion of a U tube in motion of liquid in U tube is what? SHM. Okay, so suppose first it is moving in downward, then upward, then again. So motion of a fluid, motion of liquid in U tube is what? SHM. Chalo. So now we want to prove time period. So for SHM, for simple harmonic motion, what is the time period? 2 pi under root m by k. Chalo. Now we know the value of k. What is k? What is k? 2 rho Ga. But here we want to find value of mass. So mass is equal, density is equal to mass by volume. So mass is equal to, so mass is equal to density into volume. So now what is the volume? Rho. And what is the volume? A, area, and height. What is the height? 2y. So rho A 2y by 2 rho Ga. Rho cancel. A cancel, 2 2 cancel. So what is the time period? Y by G. And what is Y, students? See, what is the total displacement? H is equal to 2y. So Y is equal to H by 2. Okay. Sure. So this is the what? Oscillation of liquid in YouTube, and that is the question number 19 in NCERT textbook. Okay, in exercise question number 19. Now we discuss another type of SHM. Now question number 18, this is one more type of SHM. See, that is what? Chalo. Now next, see oscillation of cylinder. Oscillation of cylinder in a fluid. That is also SHM that we want to prove. Now see, students, now suppose this is the cylinder. What is the height of the cylinder? H. And what is the area of cylinder? A. Cross section area of cylinder is what? Base area is what? A. Chalo, so density of cylinder is rho, and density of fluid is what? Now this is the stable condition. This cylinder is floating in a liquid. Okay, but now see how for oscillation this cylinder is moving in a downward direction, slightly depressed, slightly moving in a downward direction, then released. Okay, chalo. So what is the displacement of cylinder in a downward direction is x. What is the displacement of cylinder in a downward direction is what? X. Chalo, suppose this is the what? It displacement in downward direction is what? X. Chalo, so now see students, then when we moving in downward direction and release, then it moving in upward direction. Why? Due to the which force? Buoyant force. Okay, when we released in downward, when we pushed the cylinder in downward direction, and when we when force is released, then it moving in upward direction. So here restoring force is what? Due to buoyant force. So what is the buoyant force? As we know, m naught g. M naught g is what? Displacement mass of fluid, mass of fluid displaced by cylinder. And what is that mass? Mass is equal to what? Density into volume. But here we consider density of what, students? Fluid. Okay, અને પહેલા મેં તમને કીધું હતું કે ડિસ્પ્લેસ કોણ થાય છે? ફ્લુઇડ. તો ડેન્સિટી કોની લેવાની? ફ્લુઇડની. બટ એ ફ્લુઇડ જે ડિસ્પ્લેસ થાય એનું વોલ્યુમ કેટલું હોય? સેમ એઝ અ વોલ્યુમ ઓફ સિલિન્ડર. ઓકે, સો ઓલવેઝ density is what? કેમ કે ડિસ્પ્લેસ કોણ થતું હોય? when we jump in the swimming pool, then water is displaced, and what is the volume of displaced water? Same as a object. Okay, કોઈ જેટલું object જશે એ volume displaced થાય. So mass of fluid displaced by water, mass is equal to what? Density into volume. So mass is equal to density into volume, but density of what? Fluid, because in here fluid is displaced, mass of fluid. So density of fluid, and what is the volume? See, A, and what is the displacement? X. Chalo. So rho A x g. Now F is equal to kx, where what are the constant terms? Rho, sorry, it is sigma. What are the constant terms? Sigma, area, base area, and g. Chalo, so again we prove F is equal to kx, so it is what? SHM. Chalo, so now we want to find again time period. So if you want to find time period, then what? Two pi under root m by k. Now we know the k. K is what? Sigma ag. But what is k? Sigma into ag. But now we want to find mass. That is mass of cylinder. M is what? Mass of cylinder. Again, mass is equal to density into volume. But now this is the mass of cylinder, so we consider density of cylinder. And what is the volume of cylinder? Area into height. Chalo, so 2 pi rho ah by sigma ag. A cancel, so what is the time period? Rho h by sigma g. Okay students, so here oscillation is due to the what? When the cylinder is moving in a downward direction, then when force is released, then it again moving in upward direction. So that restoring force is due to what? Buoyant force. Okay, And in buoyant force, same, always consider the density of fluid, okay, because fluid is displaced and the volume of displaced fluid is same as the volume of object. Okay, so this is the one oscillation of cylinder in a fluid. Okay, remember this formula, students. T is equal to 2 pi rho h upon sigma g. Now next case, now next is a question number 20. So now see students, this is what oscillation of a piston in a cylinder. 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 Suppose these students this is the cylinder, okay, and see here in this is the what? Gas. What is the cross section area? Cross section area. Cross section area of piston. It is airtight piston, huh, students? Cross section area of piston is A and mass is M. Now students, this piston is moving slightly in a downward direction and then released. Now this piston is okay, this piston is depressed slightly. This piston is depressed slightly in downward direction. Now this piston is slightly depressed in downward direction. So now this piston suppose is moving downward direction by x. So see students, due to that volume, now due to that, what is the change in volume of a gas? Delta V. Okay, so when piston is moving slightly in down, depressed slightly in downward direction, then released, when what? Due to the gas, first gas is compressed, but when piston is released, gas is again expand. So this is the what? SH that we want to prove. Okay, this motion of a piston is SHM, then it can oscillate. Okay, so we want to prove that motion is SHM. Okay, motion of piston is what? SHM. Chalo, so how to prove, students? See, what is the displacement of a piston? Displacement of piston is what? Xn. Change in volume of gas is delta V. So students, first remember, whenever there is a change in volume, because when piston is depressed slightly, then volume of gas is changed. So whenever there is a change in volume, we consider what? Bulk modulus. Okay, we consider what? Bulk modulus. So what is the bulk modulus? P. Remember students, this formula પછી જોવાની છે આપણે. Bulk modulus means P upon delta V by V. Okay, P is a volume stress and delta V by V is volume strain. So what is the pressure? B into delta V by V. Okay, and what is delta V by V? What is the change in volume, students? Change in volume is what? Area into displacement. Why here we consider displacement? Because due to the displacement of a piston, in downward direction, volume is changed. So what is the change in volume? A into X. So what is the pressure? BAX upon V. Chalo. But if we want to prove SHM, then we find force. So pressure is equal to force by area. So force is equal to pressure into area. What is pressure? BAX by V. What is the pressure? Okay, so whenever students there is a change in volume of a gas, then we consider bulk modulus. Okay, chalo. So here we plot the value of pressure. So see, what is the force? B A square by V into X. So F is equal to Kx, where K is equal to what? B A square by V. Okay, so this is what, students? That motion is simple harmonic motion. That motion is SHM, simple harmonic motion. Now we want to find time period. So 2 pi under root m by k. What is k? B A square by V. So mv upon B A square. Okay, M is the mass of cylinder, V is the volume of gas or volume of cylinder, bulk modulus and area of piston. Okay, but students આ થોડા ટાઈમ માટે યાદ રાખી લેજો. B is equals to P, pressure means here pressure is also known as volume stress by volume strength. So P upon delta V by V. Okay, chalo. Now next students. So we discussed three types of different SHM. First SHM is what, students? First SHM is motion of a fluid, motion of a liquid in U tube, then motion of a cylinder in a liquid, then motion of piston, okay, in a cylinder. Sure. So now next students, see, this is the four type of simple harmonic motion. Basically in a chapter we discuss SHM motion of a spring and SHM motion of a simple pendulum and compound pendulum. These four are different cases. Now again see one case. Motion of object in tunnel of earth. Okay, motion of object in tunnel of earth. Chalo, see students, this is the earth. Radius of earth is R. This is the center. Chalo. Okay students, now suppose this is the tunnel. Okay, means tunnel means there is a cut from the earth. This is the tunnel, okay, in earth. And now in this tunnel, suppose here we consider object of mass m. Okay, now this is in this tunnel, this object is oscillate. Okay, see, first due to the gravity of earth is moving in this direction. Then again due to the gravity it moving in backward direction. Okay, એટલે પહેલાં શું કરશે, જે ડ્યુ ટુ ધ અર્થ ગ્રેવિટી ક્યાં જવાની ટ્રાય કરશે, સેન્ટરમાં. એટલે કેવિટી છે એટલે એની પાસે જે પાથ છે એ તો કેટલો છે સ્ટુડન્ટ્સ, એ આમ જ મોશન કરી શકે, આમ જ, પણ એ અર્થની બહાર નહીં જઈ શકે. શું કામ? બિકોઝ અર્થની જે ડ્યુ ટુ ગ્રેવિટી ઓફ અર્થ એ ક્યાં જવાની ટ્રાય કરે, સેન્ટર સુધી. મતલબ જો અહીંયાથી એમ જશે, હવે જેવું એ એમ જાય ને કે વધારે સેન્ટરથી દૂર જાય એટલે પાછું એને ગ્રેવિટેશન પાછું અટ્રેક્ટ કરીને આમ મોકલી દેશે, આમ મોકલી દેશે, એટલે આમને આમ ઓસિલેટ કરી શકે, એટલે કેવિટીની બહાર નહીં જાય. ઓકે, because first due to the attraction of the gravitation it moving in this direction, but દૂર જશે એટલે પાછું એને શું કરશે, gravitation attraction પાછું એને આમ લઈ આવશે. So it moving like that. Okay, So first see, suppose this is the r, radius of earth, this is x, is displacement, and what is the angle theta. Okay, see અહીંયા diagram draw કરી દઉં તમને. Here it is object, this is the displacement in a tunnel, this is x, and this is the theta. Chalo, so very easy students. See, from the center, this is the center of earth. This is the center of earth. Now from the center of earth, it experience gravitational force, because gravitational force always towards what? Center of earth. So that object in a tunnel of earth experience gravitational force towards the center, means we can say that mg. Chalo, it experience which force? mg. Chalo, so here we consider, see where the angle is formed, we consider cos theta. Where the angle is formed, we consider cos theta, and here we consider mg sin theta. But see students, in a motion of a tunnel, which component? This is the tunnel, right? This is the tunnel. See, this is the tunnel. Tunnel is horizontal. Tunnel is horizontal. So what is the horizontal force? mg cos theta. So because in that direction, which force is exact? mg cos theta. So we can say that for oscillation, for motion of object in a tunnel, mg cos theta component is responsible for motion of object in tunnel. mg cos theta is responsible for motion of object in a tunnel. Which component is responsible? mg cos theta component is responsible. Due to that component object is oscillate. Okay, now so what is the required force, students? mg cos theta. Now what is cos theta? Adjacent by hypotenuse. So x is a adjacent side and r is a hypotenuse. Chalo, so mg by r. So F is equals to kx. So see that motion is SHM, and what is the constant? mgr. What is the constant? mgr. And what is the time period? m by k. What is k? mg upon r. So what is the time period? Okay, so see students, it like moving in that direction. Okay, first it attract by the gravitation, so it moving in that direction, then again it attract by the gravitation, moving in backward direction, so on. એટલે ક્યારે અર્થની બહાર નહીં જઈ શકે, ટનલમાં મૂવ થયા રાખશે. Okay, if there is a tunnel in a earth. So and what is its time period? 2 pi under root r by g. So these are the 4 important cases of different types of simple harmonic motion. Okay, chalo, so we discuss 4 types of SHM. So now students, we want to discuss phase difference. We want to discuss phase difference between 2 particles. So now see the one type of sum. Suppose 2 particles perform simple harmonic motion. For first particle, here see what for first particle, what is the equation of displacement? X equal to A sin omega t plus pi by 6. For second particle, what is the equation of displacement? X equals to A cos omega t. આવા ટાઈપના ક્વેશ્ચન આવે છે સ્ટુડન્ટ્સ. ફાઇન find phase difference chalo. So first student see, first thing is what, suppose x equals to a sin omega t plus phi, that we know. So students, in that case, that phi is known as initial phase. That phi is known as initial phase. Suppose see this, here is the particle, okay, so it starts from here, so this is its initial phase. After some time it reach at P dash. Now what is the angle? Omega t. What is the angle after some time? Omega t. It moving at omega t direction. So what is the total angle? Omega t plus phi. That is known as phase. Okay, clear? Phi is initial phase where it start the motion. After some time it move at the P dash, means at what angle? Omega t. So what is the total angle? Omega t plus phi. That is known as phase. So we want to find phase difference. So this is known as phase. Now see students, how to find phase difference. તમારે ખાલી માઇનસ જ કરવાનું છે. But see, या तो in both the equation sin function હોવું જોઈએ, या બંનેમાં cos હોવું જોઈએ. Okay, in both the equations sin is sin or cos. હવે see, if you want to convert both the function in sin, then it is fine. So we want to convert cos into sin, this cos into, sorry, this cos omega t into sin omega t. So first equation is in proper form. Chalo. Now we want to convert this cos omega t into sin omega t. Now there are the 2 methods. Sin pi by 2 plus theta. Yeah, here omega t is also cos omega t. Sin pi by 2 minus theta, means here theta is omega t, is also cos omega t. So now if you want to convert cos omega t into sine, then we can use this 2, either pi by 2 plus theta and either pi by 2 minus theta. But see students, if we take sine pi by 2 minus theta, means here theta is omega t, then see, now we cannot compare these two. Why? Because here omega t is positive, here omega t is negative. Okay, so we cannot take pi by 2 minus omega t. Why? Because here omega t is positive, here omega t is negative. So students, that's why we take pi by 2 plus omega t. So we can now also write a sine omega t plus pi by 2. So now see, for particle 1, what is the phase? Omega t plus pi by 6. Now we can compare, we can take difference of these two particles, because here omega t sine. Okay, chalo. So for particle 1, what is the phase? Omega t plus pi by 6. For particle 2, what is phase? Omega t plus pi by 2. Chalo, so we want to find phase difference. So theta 2 minus theta 1, so omega t plus pi by 2, omega t plus, chalo, theta 2 minus theta 1, omega t minus omega t cancel, so pi by 2 minus pi by 6. Take LCM, yeah, 90 minus 60, 90 minus 30, so 60. So what is the phase difference? Pi by 3. Okay, so this is the condition, students. Okay, first what is the condition? First, in both the equation, या तो sin होवू जोई trigonometric function या तो cos. Then in both the तो no होय तो मारे convert करवानुं. But what is the condition? Omega t ની જે sin હોય same रहवी जोई. So here omega t is positive, तो आमा भी positive ज आववू जोईए. Okay, so in this way we can find phase difference between two particles. Chalo, now one more type of question, students. Chalo, now see students, for SHM, what is the equation of SHM of first particle 0.1 sine 100 pi t plus pi by 3, and for second, what is the equation? 0.1 cos pi by t. So now find phase difference of velocity of a particle find phase difference of velocity of particle of particle 1 with respect to 2. Okay, find phase difference of velocity of particle 1 with respect to velocity of particle 2. Now you want to find phase difference of velocity, student. Okay, so first find velocity. So how to find velocity? dx1 by dt, this is for first particle, and dx2 by dt for, because we want to find phase difference, but phase difference of velocity. So first find velocity, right? So velocity means dx by dt. So what is the differentiation? See, what is the differentiation? What is x1? 0.1. What is the differentiation of sine cos 100 pi t so what is x1? 0.1. What is x1? 0.1 sine 100 pi t plus pi by 3. So 0.1 cos 100 pi t plus pi by 3 into, okay, what is the concept? Multiply with the coefficient of t. What is the coefficient of t? 100 pi. So 0.1 into 100 pi. So 10 cos 100 pi t plus pi by 3. So now for second, now velocity of second, what is x2? 0.1 cos pi by t. So what is the differentiation of cos? Minus sine pi t into, what is the coefficient of t? Pi. So 0.1 so minus point, what is the differentiation of cos? Minus sine, so minus 0.1 pi. Why here pi? Because multiply, what is the rule of differentiation? Multiply with the coefficient of t, and what is the coefficient of t? Pi. So now students see, what is that velocity? Minus 0.1 pi sine pi t. Chalo, now we want to convert this sine. See, for in first case, what is the velocity? Cos. So either we can, but see here again, what is the problem here? It is minus, negative sign. So first we want to convert the negative sign into positive. So as we know, here we write pi by t plus pi. Why we write here pi? Because negative sign is there. Chalo. So now see what is the velocity here, cos. So now as we in a previous question convert this cos into sine. Hundred pi t plus pi by 3. How to convert cos into sine? Because what is the formula? Sine pi by 2 plus theta is equal to cos. Okay. So in the place of cos we write what? Pi by 2 plus theta. So why here we convert cos into sine? Because this is in sine. So sine, first this is our total theta. So write theta plus pi by 2. Okay, why we write here pi? Because negative sign is there. So we write plus pi. Why we here we write pi by 2? Because we want to convert cos into sine. Sure. So 100 pi t, pi by 3 plus pi by 2. 5 pi by 6. Now students, see this is the correct comparison, because see both sine, here omega t is positive, here also omega t is positive. See students, it is not 100, it is only it is not 100, or it is only pi. It is only pi, so not 100, it is only pi. Chalo, so here we write what? 0.1 pi. Chalo. It is only pi students, there is mistake in a question, only pi. Chalo. So see, now we want to find phase difference of velocity of particle 1 with respect to time. Phase difference of 1 with respect to time. So first we consider 1, because I have 1 apelu છે પહેલા, so we consider 1. So theta 1, why we here consider 1? Because velocity of particle 1 with respect to 2. So what is the phase? Pi by t, pi t plus pi by 6 minus, what is that? Pi by t minus pi. So 5 pi by, this is cancelled, so 5 pi by 6 minus pi. Okay, chalo. So in this way we can find phase difference of velocity also.